Hello, welcome to Ilma. Now, in the previous classes, we had completed rational and irrational numbers of class 9 syllabus. Now, we will be continuing with class 10 syllabus, factorization of both Icse and CBSE. So, today we will be discussing about the first part of factorization, which will be mainly remainder theorem. And there will be further parts to discuss the remaining parts. And for now, let's get started. So the main thing we are going to study today is the remainder theorem. Now the remainder theorem states that fx is the remainder of a polynomial. F here means function of x. For this means actually the remainder. This is the abbreviation for remainder. Therefore, fx of a polynomial can be any algebraic expression written in terms of an variable. For example, x cube plus x square plus x plus 2. For this would be a polynomial where x is the algebra. Now, there are different types of polynomials based on their degrees. Now, polynomials can be of degree 1, starting from x, which will be of x, and degree 2, which will mean x squared, and degree 3, which will be x cubed. Now, x to the power 1 means for degree 1, x to the power 2 means degree 2, and x to the power 3 means degree 3, and this will be carried on. Now we will continue. So this one here is a polynomial of degree 3 because x to the power 3 is present here, so others will be neglected here. Now we will be given, or we will have to find out a number by which we will have to divide this to get the remainder. For example, that number is x plus or x minus a. Here, x minus a, we will assume that x minus a is equal to 0. Therefore, x is equal to a. Now, we will use the value of x we got from assumption in here, and for that we will write it like f. X will become a, and x cube will become a cube plus a square plus a plus 2. Now this will be the remainder of the polynomial. Here a is any number, any integer, so this on simplification it will lead us to the remainder, which will be fa or fx. Fx and fa are equal in this case. Now there might be some cases in which the number we need to divide the polynomial by is written like this: 2x plus 1. Then first of all, if there is a sign between the variable x and another constant which will be an integer, and that sign is positive, we will take generally the negative sign, because the number will go to the other side substituting 0. For example, here plus, it is plus, so it will become minus. 2x plus 1 is equal to 0, assumed. Now 2x is equal to minus 1. It becomes minus 1, and x will become minus 1 by 2, taking the value of 2 here. Now thus it was plus here and it became negative. Now this was all we need to know about remainder theorem. We will do one question of what I have shown until now. It will be fx is equal to 3x cubed minus 7x squared plus 4x. 3x cubed minus 7x squared plus 4x is equal plus 11. where it is given to us that the value is of given by for division is 2x plus 1. Now 2x plus 1 will be assumed to be 0. Let 2x plus 1 be 0. Therefore 2x plus 1 is equal to 0, which will give us 2x is equal to minus 1, which will give us x is equal to minus 1 by 2. Now we have the value of x. We will substitute it over here. So it will be fx, which will be f minus 1 by 2, substituting the value, is equal to 3 minus 1 by 2 cube minus 7 minus 1 by 2 square plus 4 minus 1 by 2 plus 11, which will be 3 minus 1 by 2 cube. Minus 1 cubed will be minus 1 itself, because cube will not change the sign of the number, but only cube the integer. And 2 cube will be 8. Therefore 3 into minus 1 by 8, which will be is equal to f1 minus 1 by 2 is equal to minus 3 by 8 minus, it will be 1 by 4, sign will be changed because it is square, and 2 square, which will be 4, 1 by 4 into 7, 7 by 4, which will then be 4 and 2 will cancel each other, it will be minus 2 and plus 11. Now we will simplify this by multiplying all of these, or taking the LCM by simplest mean. 8, it will be minus 3, minus 14, minus 16 and plus 88. Now it will be minus 3, minus 14, minus 16, summing them up will get minus 19, minus 14, minus 29, minus 33 plus 88, which will be 55, is equal to 55 by 8. So this will be the answer, which will be fx will be 55 by 8 for this. This is the remainder. Now we will do another sum in which we will not have to find the remainder but a variable within the expression. That would be the number is x cube plus 5x square minus ax plus 6, minus ax plus 6. We have to divide this number by x minus 1, which will be x minus 1. Here we need to find a, and the number we need to divide this polynomial will be x minus 1. So let x minus 1 be 0. Therefore x is equal to 0 by directly, and we will substitute the value of x over here. Therefore f1 is equal to 1 plus 5, 1 square is 5 itself, minus a into 1, 1, which will be a minus a plus 6. Now 5 plus 6, 11 plus 1, 12, which will be 12 minus 8. Now this is given, and the remainder for this was 2a. Now they have given the value of f1, which is the remainder, as 2a. Therefore 2a is equal to 12 minus a. Taking a to this side, we will get 3a is equal to 12. A is equal to 4 by taking 3 over as the denominator. Therefore we found the value of the variable a in this polynomial, which would be 4. For this current, for dividing it by this and giving the remainder as 2a. Now we will do another type of sum, which will be the one of the top level of factorization, remainder theorem. It is ax cube plus 3x squared minus 3 f x, let this be, or it has given r1, so let it directly take it as r1, which is the remainder. R1 is equal to ax cube plus 2x square minus 3, and R2 is equal to 2x cube minus 5x plus 8. We will get, now here they have given that it is being divided by x minus 4. So the number here is x minus 4. Taking x minus 4 as 0, we get x is equal to 4. Putting x is equal to 4 over here, therefore r1 is equal to 4 cubes are 64 is equal to 64a plus 3x square, 16 into 3 plus 48 minus 3. Therefore r1 is equal to 64a plus 45. Now r2 we need to find out. R2 is equal to, x will be 4, therefore 2x cube will become 64 into 2, 128, minus 5x will be 20, it will become 20 plus 8. Now they have given the relation between r1 and r2, which will be 2r plus r2. 2r is equal to r2. Therefore 2r1 is equal to r2. Yes. Now we have found r1 has 64a plus 2, 45, and r2 has 128 minus 20 plus 8, which will be 108 plus 8. Now we substitute the value of r1 and r2 in this equation. We get 2 twice of 64a plus 45, which was r1, is equal to 108 plus 8. Now it will be 128 a plus 90 is equal to 108 plus 8. It will be 90 minus 108, which will be 18, and 128 over here, therefore 18 plus 8, and a will come here, therefore 127 is equal to 18 is equal to, a is equal to 18 by 127, 39, 3 6 3, no, it is not. So this was how it was done. The value of x was 2. It will be 3, 4, 16, 48. Yes, it is. So this was the value of a, which will be 18 by 127, and 1 minute, let me see. 64, and x square, 16 into 3, 48, minus 3 will be 48, 45, and then, so the first expression is correct, and then the R2 one, which will be 2x cube, which will be 64 into 2, 128, and 5x, which will be minus 20 plus 8. Yes, it is correct. Okay, so these were the sums on factorization for remainder theorem, and we will be continuing the next part from tomorrow, which will be mainly consisting of factor theorem. So this was all for today. You may post your doubts or queries in the comment section and or in my WhatsApp number 98749444154. So thank you.
And I will solve 2.